February 19, 1943. Lieutenant Takeo Shibata pulled his Mitsubishi A6M Zero into a hard banking turn 18,000 feet above the Solomon Islands. He was chasing an American F-4F Wildcat, the same maneuver he had executed hundreds of times, the same turn that had made the Zero legendary, the aircraft that could outturn anything the Allies had. But this time, something was different. He felt a vibration through the control stick, a shudder that should not have been there. Then he heard it, a sound no pilot ever wants to hear, the sharp crack of metal failing under stress. His left wing folded upward like paper. The Zero, Japan's technological masterpiece, the aircraft that had terrorized the Pacific for over a year, simply broke apart in mid-air. Shibata never made it to his parachute. The wreckage scattered across 10 miles of jungle. When the maintenance crews recovered what was left of the aircraft, they found something that terrified them more than any American fighter ever could. The wing spar, the main structural beam that holds the entire wing together, had developed massive stress cracks. Fractures that spread like spider webs through the aluminum. This was not battle damage. This was not a design flaw. This was something far more catastrophic. The metal itself was failing, and Shibata's Zero was not an isolated case. It was the beginning of a nightmare that would destroy Japanese naval aviation from the inside out. By mid-1943, reports were flooding into Japanese Naval Air Command from every front. Zeros were breaking apart during routine maneuvers. Wings were cracking after just 200 flight hours when they were designed to last 800. Fuselages were developing stress fractures that made aircraft unsafe to fly. Pilots were dying not from enemy action, but from their own planes betraying them in mid-flight. The Americans had no idea this was happening. They were still fighting desperate battles in the Solomons. They were still losing pilots to the legendary Zero. But deep inside Japan's war machine, in the metallurgy labs and aircraft factories, engineers were facing a terrifying truth. They were running out of aluminum, and without aluminum, modern aircraft simply cannot exist. To understand how catastrophic this crisis was, you need to understand what the Zero represented in 1941. When it first appeared over Pearl Harbor and then the Philippines, it was not just superior. It was a revolution. The Zero could fly farther than any carrier-based fighter in history. It could outturn every aircraft the Allies possessed. It could climb faster and fight at higher altitudes. American pilots who survived encounters with it filed reports that sounded like they were describing science fiction. The secret to the Zero's performance was extreme weight reduction. Every single component was engineered to be as light as possible. The designer, Jiro Horikoshi, had been given an impossible task by the Japanese Navy. Build a fighter that has the range of a bomber, the maneuverability of a biplane, and the firepower to dominate the sky. The only way to achieve this was to use advanced materials, specifically a top-secret aluminum alloy called Extra Super Duralumin. This alloy, developed by Sumitomo Metal Industries, was stronger and lighter than anything the Americans or British were using at the time. It had a tensile strength of over 60,000 pounds per square inch. It was produced using high-purity bauxite ore imported from the Dutch East Indies and Malaya. The refining process required enormous amounts of electricity. The alloying process demanded precise temperature control and specific trace elements. Every Zero that rolled off the Mitsubishi assembly line in 1941 was built from this miracle metal. It was the foundation of Japan's entire naval air strategy. But that foundation rested on a supply chain that stretched thousands of miles across the Pacific, and that supply chain was about to be cut. The crisis began not with a battle, but with a map. When Japan launched its attacks in December 1941, they seized the resource-rich territories they desperately needed. The Dutch East Indies provided bauxite, the raw ore that becomes aluminum. Malaya provided more bauxite and tin. The Philippines provided chromium and manganese, essential alloying elements. For a brief moment, Japan controlled everything it needed to sustain its war machine. But Japanese naval planners made a fatal assumption. They assumed they could hold these territories. They assumed they could ship the raw materials back to Japan. They assumed their merchant marine could operate safely across the vast Pacific. They were wrong on all counts. The American submarine force, operating out of bases in Australia and Pearl Harbor, began a systematic campaign of destruction against Japanese shipping. In 1942, American submarines sank over 1 million tons of Japanese merchant shipping. In 1943, they sank over 1.8 million tons. By 1944, they were sinking over 2.7 million tons per year. Every bauxite freighter that left the Dutch East Indies faced a gauntlet of submarines. The journey from Surabaya to Osaka, over 3,000 miles, became a death sentence. Convoy after convoy was intercepted. Ships loaded with thousands of tons of bauxite ore went to the bottom of the Pacific. The submarines were not just sinking ships, they were strangling Japan's industrial capacity. By early 1943, aluminum production in Japan was collapsing. The Showa Denko plant in Kawasaki, the largest aluminum refinery in Japan, was receiving less than 40% of its required bauxite. The massive hydroelectric plants that powered the smelting process were running at reduced capacity due to coal shortages. Another resource being strangled by the submarine blockade. Japanese engineers faced an impossible choice: stop building aircraft entirely or find alternative sources of aluminum. They chose the latter, and it was a disaster. With high-purity imported bauxite cut off, Japanese metallurgists turned to domestic sources. Japan does have some bauxite deposits, primarily in Yamaguchi Prefecture, but the ore quality was abysmal. It contained high levels of iron, silicon, and other impurities. When this low-grade ore was refined into aluminum, the resulting metal had only 70% of the strength of the extra super duralumin used in 1941. The second source was even worse: recycling. Japan launched a massive national campaign to collect scrap aluminum. Every household was ordered to donate pots, pans, utensils, anything made of aluminum. The propaganda posters showed housewives proudly handing over their cooking pots to build fighters. But scrap aluminum is contaminated. It contains traces of food acids, oxidation, and mixed alloys. When melted down and reprocessed without proper refining, which Japan no longer had the resources to do properly, it produces metal with inconsistent properties. Strength varies wildly from batch to batch. Some ingots were acceptable, others were dangerously weak. Aircraft built from this recycled aluminum were a lottery. Some performed adequately, others were death traps waiting to fail. The engineers at Mitsubishi knew this. They issued increasingly desperate warnings to Naval Air Command. Test reports from 1943 showed wing spars cracking under loads 30% lower than design specifications. Fuselage frames were showing fatigue after 200 flight hours instead of 800. The metal itself was failing, but Japan had no choice. The alternative was to stop building fighters entirely. So they kept building them, knowing that every aircraft that left the factory was weaker than the one before it. The impact on combat operations was devastating in ways that went far beyond just structural failures. Pilots who had trained on early production Zeros, built with high-quality aluminum, suddenly found themselves flying aircraft that handled differently. The wings flexed more under G-loads. The control surfaces felt mushy. The aircraft could no longer sustain the high G-turns that had made the Zero legendary. American fighter pilots began noticing something strange in mid to late 1943. Zeros were no longer as aggressive in dogfights. They seemed hesitant to pull hard turns. What the Americans did not know was that Japanese pilots had been ordered to limit their maneuvering. They were told to avoid high-G combat turns whenever possible. Not because they lacked courage, but because their aircraft could not physically handle the stress. Squadron commanders were issuing orders that would have been unthinkable a year earlier. Do not exceed 6 Gs in a turn. Do not perform snap rolls. Do not dive at speeds exceeding 350 knots. These were not tactical recommendations. These were structural survival limits. The legendary Zero, the aircraft that had dominated through maneuverability, was now prohibited from maneuvering. The psychological impact on Japanese pilots was crushing. They had been trained to believe their aircraft was superior. They had been told the Zero was invincible. Now they were watching their wingmen die not from enemy fire, but from their own wings folding in combat. Trust in their equipment evaporated. Morale collapsed. By late 1943, Japanese naval aviators were reporting stress fractures on aircraft with as few as 150 flight hours. Maintenance crews were finding cracks in wing spars on brand new aircraft that had never seen combat. The Mitsubishi plant in Nagoya, the primary Zero production facility, was building fighters that were structurally compromised the moment they rolled off the assembly line. The Americans, meanwhile, had no shortage of aluminum. The United States in 1943 produced over 920,000 metric tons of aluminum. Japan produced less than 70,000 tons, and most of that was substandard quality. American aircraft were being built from high-purity aluminum smelted from bauxite imported freely from Jamaica, Suriname, and British Guiana. The Atlantic sea lanes were secure. The supply chain was unbroken. An American F-6F Hellcat built in 1943 had aluminum components that met or exceeded every design specification. The metal was consistent. The quality was uniform. When an American pilot pulled 8 Gs in a high-speed turn, the wings did not crack. They flexed and returned to shape exactly as designed. This was not because American engineers were more skilled. It was because American industry had access to unlimited high-quality raw materials. The Japanese had the knowledge. They had the skilled engineers and designers. What they did not have was bauxite. And in modern industrial warfare, knowledge without resources is worthless. The aluminum crisis was just one piece of a larger pattern of industrial starvation. By 1944, Japan was also running critically short of aviation gasoline, another product dependent on oil imports cut off by submarines. They were short of rubber for tires. They were short of copper for electrical wiring. They were short of high-grade steel for engine components. Every single input required to build a modern aircraft was being strangled. But aluminum was special because its failure was invisible to the enemy. When an American submarine sank a tanker full of aviation gasoline, the immediate effect was obvious. Planes could not fly without fuel. But when submarines sank bauxite freighters, the effect was delayed by months. The aluminum refined from that ore would have been used to build aircraft that would not fly until 6 months later. By the time those weak aircraft started falling apart in combat, the submarines that caused the problem had already moved on to new hunting grounds. The Americans were destroying Japanese air power in advance, killing pilots who had not even been born when the bauxite freighters were sunk. By mid-1944, the situation had become apocalyptic. The Mitsubishi factories were producing Zeros that were essentially flying coffins. Structural failures were occurring at a rate of nearly 15%. That means that for every 100 Zeros built, 15 would suffer catastrophic structural failure before reaching 300 flight hours. Some broke apart during high-speed dives. Others lost wings during combat turns. Some simply disintegrated during carrier landings due to the stress of the arresting hook pulling against weakened airframes. Japanese maintenance logs from 1944 make for horrifying reading. Aircraft are grounded due to wing cracks. Entire squadrons are declared non-operational due to structural concerns. Inspections are finding stress fractures in aircraft that have seen minimal combat. The Zero, which in 1941 had an operational readiness rate of over 90%, was by 1944 struggling to maintain 50%. Half of all aircraft were too structurally compromised to fly safely. The final indignity came with the kamikaze campaign. When Japan began using aircraft as guided missiles in late 1944, one dark advantage emerged. Structural integrity no longer mattered. If the plane only needed to fly one mission before being deliberately crashed into an American ship, it did not matter if the wings were cracked. It did not matter if the fuselage was developing fractures. The aircraft only needed to hold together for 2 or 3 hours, just long enough to reach the target. Japanese engineers reportedly wept when they realized this. They had spent years perfecting the Zero as a fighting machine. Now they were building disposable missiles from scrap metal, flown by teenage boys with barely 50 hours of training for one-way missions. The aluminum crisis had reduced Japan's air force to this. The final accounting is brutal. American intelligence estimated that structural failures destroyed more Japanese naval aircraft in 1943 and 1944 than combat losses in some months. Exact numbers are impossible to determine because Japan destroyed most records before surrender. But post-war interviews with surviving Japanese pilots and engineers paint a consistent picture. By 1944, Japanese naval aviators feared their own aircraft almost as much as they feared American fighters. The psychological impact of not trusting your aircraft in combat is impossible to quantify, but it is certainly fatal. When a pilot hesitates to pull a hard turn because he fears his wing will fold, he is already dead. The aluminum crisis was not a single dramatic event. It was a slow, invisible strangulation. It was the perfect example of economic warfare. The Americans did not need to shoot down every Zero. They just needed to sink the bauxite freighters. The submarines operating thousands of miles from the air battles over the Pacific were the ones who truly defeated Japanese naval aviation. They killed pilots who never saw them. They destroyed aircraft that had not yet been built. They won battles that would not be fought for months. This is the nature of industrial warfare. Victory does not always come from superior tactics or braver men. Sometimes it comes from controlling the resources that make modern weapons possible. Japan had the courage. They had the skill. They had brilliant engineers and fearless pilots. What they did not have was aluminum. And in the end, that was the only thing that mattered. When Lieutenant Takeo Shibata's Zero broke apart over the Solomons in February 1943, he did not die because of American fighters. He died because an American submarine had sunk a bauxite freighter off Java 8 months earlier. The war was already over. Japan just did not know it yet.